In this video, you are going to learn how to calculate or find percent error using proportion, or what we call proportional reasoning, using this example on the screen. Sean estimated that the attendance at a college lacrosse game was 3,000. The actual attendance was 3,296. What is the percent error of Sean's estimate? Round to the nearest whole percent. Before we can start calculating the percent error, first we need to know what we mean by percent error, estimated value, and actual value. So what is percent error? So percent error basically describes the accuracy of a measured or estimated value compared to an actual value. It is always a positive percent. That means when you find the percent error, it cannot be negative, it must be positive. What do we mean by estimated value? Estimated value is the same thing as an approximation, a guess, not really exactly, it's not exact. An actual value is, in this case, actual attendance. This is basically the number of persons that attend when they were counted. Those are the actual persons that attend the game. All right. So in establishing those definitions, let us go into calculating the percent error. So in the problem here, the value for the estimated, the quantity for the estimated value is 3,000 minus the actual value, as it says, actual attendance is 3,296 divided by the actual value, which is again 3,296, equals to percent over 100. So we don't have to write the entire word percent here. We can just use P to represent percent, since P is the first letter of the word percent. So P is our variable, P is our unknown, P is what we are finding. So now that we have substituted our values into the proportion, we are going to start by simplifying the numerator because it looks a little bit complex here. So let us simplify. So 3,000 minus 3,296 is going to give us negative 296. Then we write back our denominator, which is 3,296 equals to P over 100. So when you take the negative, the absolute value of a negative number, it becomes positive, as you see here in the definition for percent error. The percent has to be positive. It cannot be negative. So we need to get rid of this negative number by taking the absolute value of that negative number. So as we said earlier, once you take the absolute value of a negative number, it becomes positive. So we are going to have positive 296 over 3,296 equals to P over 100. Now that we have a proportion that we are familiar with, we are going to go ahead and start solving our proportion by cross multiplying, which is the same thing as the butterfly method. So we are going to see 3,296 times P give us 3,296 P equals, and 100 times 296 is equals to 29,600. Right now we have what we call a one-step equation. We need to find the value of P, which is the variable that is on the left-hand side of the equal sign. To do that, we need to isolate the P by getting rid of the number in front of the P. To do that, we divide by that same number, all right? we use what we call inverse operation. So whatever is happening to the P, we do the opposite. So if we divide the left-hand side by 3,296, we are going to do the same thing to the right-hand side of the equal sign. So 3,296 into itself goes 1. 3,296 into 3,296 goes 1. 1 times P is 1P, or we can say P. And when we divide 29,600 by 3,296, we are going to get approximately 8.9, 98%. Going back to our problem, it says, what is the percent error? So we got 8.98%. But also a part of our problem says we must round to the nearest whole percent, meaning that we don't need a decimal, we need a whole number. So how do we round this? 8.98 rounded to the nearest whole number. So our digit in the whole number, the first whole number place value here is 8. Identify the digit you're rounding to. Look next to that digit. If that digit is 5 or more here, in this case we have a 9, you add 1 to the digit you are rounding to. So if I add 1 to 8, I am going to get 9. So my answer is 9%. So now let me answer the question. The question that we were asked in the problem, it says, what is the percent error of Sean's estimate? So the percent error of Sean's estimate is 9%. So he made a 9% error in his estimation when he estimated the number of persons that would attend the lacrosse game. And that is how we use proportion to calculate our fine percent error.